today we are going to talk about reactive programming with RxJava, and our facilitator today is Mayowa. So Mayowa has over 7 years of mobile application development, both in native and hybrid development. He has spent many of those 7 years designing and architecting new and existing solutions. He has also contributed to projects in a myriad of industries: finance, telecom, education, data, etc. And currently, Mayowa is actually a senior software engineer here at Andela and is currently working with one of our partner companies called Premise Data. So Mayowa, welcome. Thank you for being our facilitator today. You can go ahead, introduce yourself, probably tell us a bit about Premise Data, and then kick off for the 1 hour.
Cool. Well, thank you so much, everyone. So my name is Mayowa, and like Messi mentioned, I have over 7 years of Android development experience. And before Andela, I've worked with a number of companies in Nigeria. And today, what I just want to do is I want to take us through what reactive programming is and how we can apply it to different technologies depending on the kind of frameworks that we're using. Majorly in this session, I'll be doing a code demo with the Android environment. Not really Android, it will majorly be Java environment in itself. But a lot of it, I'll try to focus on what the application of reactive programming is, what it is in real essence, and how we can really apply it to our everyday programming if we need to adopt it in what we do as a developer. So I have been developing reactive paradigm for over 3 years now, and I've had a lot of advantages around this. So I just want to introduce us to it as well. So thanks so much, everyone, for spending this time with us. So the way this session is going to go is I've prepared a few slides around this, but majorly a lot of it is going to be around the code demo in itself, just showing us what the output looks, what the code looks like, and what it means in practicality for this session. So I hope we would enjoy it. If there's any question, feel free to drop it on the chat, and I would attend to them. Thank you. So like I mentioned, this session is reactive programming, and then we'll be talking about Rx observables, operators, and then showing us the code demo. And just to I'll give us some background on what reactive programming is, just for some of us who may be new to it, and then we're just sharing it for the very first time. So I'm going to give us background around it, what it means, what the applications are. And then I also tell us the different kind of frameworks and libraries that we have for reactive programming and what observables are. But another thing that is also important is to talk about the concurrent operations that we can perform with reactive paradigm, which is using multi-threading. And this is really the major benefit of reactive programming that gives us the multi-threading benefit, and then it allows us to perform a synchronous operation out of the box. And another one that I'll be interested in talking about in this session is the error handling. So we have the traditional method of try-catch in a lot of programming for handling error, but reactive paradigm comes with a little different style. And I also want to talk about this in this session, and then we'll go to Q&A as well. This is not everything about reactive programming, and then at the end of this slide, I will show some of the things that we also need to talk about maybe in the future. Yeah, so what is reactive programming? So the simple way I can describe reactive programming is that imagine that you have a source and then you have an observer. Another name for an observer is, you can say, a subscriber in itself. So you have a source and an observer, and then the source emits data, and then the observer or the subscriber is listening to that data. That is the whole idea around reactive programming. So basically, an observer is listening and reacting to changes that is emitted by the source. That's what reactive programming, that's the concept in the simplest term. And in reality, in terms of the practicality of how is this relevant, a lot of uses for reactive programming is to help us simplify asynchronous operation. A lot of us has dealt with asynchronous operation in our daily programming. Asynchronous operations like basically you want to perform something out of the main flow. That is an asynchronous operation. So if you want to say, you want to perform a DB call, an API request, you don't want to put that on your main flow because it probably blocks your main thread and the likes. So you try to divert that flow into a different thread. And then once the result is back, then you return the result to your main flow in itself. So we have different approach. We do that. In Java, you have in Android, you have things like async tags to help us perform asynchronous operations then. And then you have things like handlers in Java as well to help you manage these asynchronous operations. But they come with some complexity. And when you have to start managing a lot of these asynchronous operations, especially when your asynchronous operation goes from asynchronous, just one asynchronous operation, to multiple concurrent operations, then you have to start thinking about how do you manage your thread, how do you dispose a thread, how do you ensure that you are not running out of threads in a life. So that's it about asynchronous operations, and the goal of reactive programming is to simplify how we code asynchronously. And if we think about our daily programming in itself, a lot of what we do in programming, they are synchronous. But what's unfortunate is that programming is synchronous in nature. So what it means is that your code will have to execute one step after the other. That's the way programming execution works. So one step after the other. But if you look at a lot of use cases that we have to handle in what we code, most of them are synchronous use cases. And so why not have something that we can default to more of asynchronous programming paradigm than trying to push an asynchronous programming paradigm into a synchronous flow. So if we can adopt something that is more asynchronous in nature, then it makes our life a lot easier. So when I say a lot of our use cases are more asynchronous, what are these use cases I'm talking about? I'm talking about even our click events on UI. They are synchronous. Think about asynchronous as something that you don't know when it will occur, or you don't know when it will finish. That's the best way to really describe what an asynchronous operation is. If something is going to occur when you don't know, it's asynchronous. It means it's going to eat you when you don't know. Another way to see it is if something is going to end at a point that you are not aware of or you are not in control of, it's also asynchronous, which is the typical case of API request. You don't know when it's going to end, and then it's going to come back. When it ends, that's when you perform whatever you need to perform. But in a situation of click event, you don't know when your user is going to click on that button on the screen. You don't know when they are going to perform an action on the screen. You don't know when all those things are going to happen. So why not undo them asynchronously to make programming easy? So I try to mention in my slides here some of the example of asynchronous operations and how it's applicable in a lot of our use cases. And another thing that I think is worth mentioning, so we don't run into confusion, because I've seen a lot of this confusion online, is that asynchronous programming is not reactive system. So a lot of people say when you're programming reactive programming is not reactive system. A lot of people think when you're programming reactively, it means you are building a reactive system. There are two different things. A reactive system is building a system to scale. So take for instance, there's a lot of workload hitting your server, and then because there's a lot of workload, probably you'll try to increase your Redis cache to manage this handling. That's a reactive system, a system that is responding to size, changing in size based on the traffic that is hitting the server. But in this case for reactive programming is a callback or programming paradigm that says that there's a source emitting data and there's somebody observing the data, which is different from a reactive system that scales server resources or whichever resources based on the requests that are coming in. And I try to put a diagram here to show us what reactive programming could look like, or asynchronous programming, where you have a click event, you retrieve something from the server, you get it back, and you try to update your UI. This is like the typical style or the typical things that we have to do in our programming days. So what are the things about reactive programming? What are the core concepts of reactive programming itself? So there are three main core components of reactive programming. One is observables, the other one is operators, and the last one I'm going to talk about is the observer. Typically, you just need observables and observer, but the good side is we have reactive libraries that comes with a lot of operators that makes this programming, that makes this transformation a lot easier for us. So if you look at the diagram that I have here, I try to divide the section on the screen. So to the side of the observables, I try to also divide it to where does the operator comes in, and I also try to divide it to where does the observer comes in. So when you're trying to undo a click stream or a click event, or you're even trying to make an API call to the server, that's where observables come in, because you're going to emit data from the source, which is the call to the server in itself. And then once the call to the server comes back, there's probably a transformation you want to do. Sometimes you want to transform from the server DTO to your application DTO, just a data transformation, or probably even a POJO object. They're just trying to transform from one form to another form. And then the last part is, at the end of this transformation, you want your UI to react to this data that you fetched. And so you have things like the observer trying to listen to that changes, which is the data that has come in, and then your UI respond to that data either by rendering the data or just displaying the list of whatever you fetched from the server. Yeah, cool. So now I've mentioned about observables, operator, and observer. Now what I want to do now is I want to talk about observables in this session. And one of the things I want to talk about is what are the different kind of observables that we have, with major focus on RxJava in this case. Now we have like 5 different observables in RxJava 2. Before RxJava 2, we did not have Flowable before RxJava 2. And currently now we have Flowable in RxJava 2, which are and then aside from the Flowable, we have the single, observable, completable. It's not complete, it's completable, sorry for that error. And then you have the maybe. Now, the simple definition of a single is that you have an observable that emits only one data. That's the simple definition of a single. So once an observable emits just once, and after that emission, it terminates. That's a single. It's only allowed to emit one data. And that's the reason why I have in this diagram just one eclipse that says emitting one data. And then you have a flowable that can emit multiple data based on the amount of data that needs to emit. And then it's not restricted to 3. It can be more than 3, as much as needs to be emitted. And for a completable does not emit data. What it does is that it tells you when your subscription or the operation that you're trying to perform, it tells you when it has completed or if it fails. So it doesn't tell you, it doesn't emit any data for you, it just tells you, oh, this action has completed, this action has failed. No need for a data in itself. And for a flowable in RxJava is the same thing as an observable. They're both the same thing. The only difference between a flowable and an observable is that a flowable has the concept of back pressure. And the reason why we need that is because there are situations where you'll be emitting data, and I told you, let me go back a little. I told us that we have an observable and we have an observer. So an observer is listening to data emitted from the observable. So we could run into a situation where the observer, which is also called the subscriber, cannot respond to data at the rate that the observable is emitting the data. So at that kind of situation, we would need a situation of saying, how do we handle the back pressure? How do we manage the data? Just because the observer cannot handle it at the rate of emission. So we can have a lot of different, we have different back pressure strategy. We can choose to buffer the data to say that, let me just keep this data, and once the observer is ready for it, I'll push it to the observer. So we have a back pressure strategy for that, which is buffer. And we also have another back pressure strategy, which is drop the data in itself. So that says that if the data comes in and the observer is not ready to get the data, just drop the data and move on to the next one that comes in. So there are a lot of back pressure strategy that comes in for Flowable. And then we have something called maybe. And maybe is maybe it tells, as the name describes, it tells us that it's either this observable can emit a data or it does not emit a data. That's a maybe in itself. So it's either it emits with a single data or it does not emit with a single data. So at this point, I think I'm just going to go into my IDE to show us what this looks like in terms of how do we create an observable and how do we create some of these things that I've mentioned there. Now, can you all see my can we see my IDE? Yep. Yeah, I assume we can see my IDE. Good. So based on this, what I've done here is this is a Java program with a main operation. And so what I'm doing here is I want to demo how we can create a single observable and how we can create an observer and how we can subscribe to it. So this is a normal main function, and I'm writing it in Kotlin, not Java. So at this point, the first thing that I create is it's a disposable. We call it composite disposable. It collects collections of disposable, and I'm trying to create a mock database client at this point here. So I've created an instance of database client. My assumption is that we're trying to interact with the database in itself. And at line 27 to 29, what we have here is that we're trying to create an observable called single. That's what we're trying to create in line 27 to 29. And what I've done here is just to say that create an observable from this method, from callable method, then call the database client to get the user object, and then I'm passing the user object with the ID of the object. Now, for now, it's currently at -1. I'm going to pass in 1. The assumption is I'm trying to make an assumption that the ID that I'm passing is a valid ID in itself. So I'll put in 1 for now because I want to demo a successful use case and I want to demo an error use case for us. And the other part, which is line 31 to 34, is an observer in itself. So what I've done here is I'm creating an observer, and in Kotlin, this is the way you can create the observer. You'll notice there are 3 callbacks for the observer. There is on success callback, there is on subscribe, and there is on error in the callback. And yeah, so you create the observer, and now that we have this observable, we have the observer, then I can subscribe to it in line 47. So I have single from callable subscribe to this single observer in itself. Now, the final line, which is line 49, is to dispose my subscription. That's line 49. And one of the things that I would just like to touch briefly is that when you're creating in the RxJava concept, when you create an observable and you create you do a subscription, you need to learn to dispose your subscription. In this case, what I'm just doing is that I'm disposing my subscription at the end of the flow in itself. And in a normal, probably Android environment, you probably want to dispose your subscription after you're on destroy lifecycle or you're maybe on stop lifecycle, as you may name it. Now, what I've done here is I've run this operation, and what you can see is that currently it's telling me the data that is being fetched, because if you look at line 34, it tells me data observed, and then it tries to print out the data that we got from the proxy, which is the full name, and then it tries to say Williams Schiller. This is what I've programmed in the database client for it to return. So it returns the result in the onSuccess method, and this is the result that it returned. It only returns the result once. Now, another thing that I also want to mention is that what happens if this is going to fail in this situation whereby it's not able to fetch the result. So I will try to put -1 here, which is in a typical scenario, we would not expect the user object to be -1, the user ID to be -1. So what I've done in my DB client, if you can see my method here, is that I've said that if the user object is equals to -1, just return a null data. Okay? Now, it's returning a null data because the user object is -1. Now, let's see what happens in this case that it's -1. Yeah, so this is what happens. We get this error message that says that null pointer exception, the callable returned a null value. Now, that's one interesting thing about RxJava is that it is not saved with null data, null result. So if you try to return a null result in your Rx stream, then Rx is going to complain. It's going to make noise that something is wrong. And then what's going to happen is going to return to a result to an error, and then your stream is going to terminate. One of the things that happens when there is an error in your Rx stream, in your flow, is that your stream terminates, and subsequently you can't get data from that stream anymore. So in this case, what has happened is that we're trying to fetch a user with a wrong ID, and then it returns a null object, and then the stream is terminating, which means that it is calling the on error callback in this case here. And then what you're seeing here is a stack trace message, which we have printed here. So one thing that we need to know is that it is not a crash. It's just a stack trace message which we have printed, and your stream will not be able to listen subsequently to emission, or nothing is going to come out of your stream anymore. But what happens if, for instance, I decide not to undo the on error callback? What happens in that case? So, okay, before I get to that case, let me just try to, there's also this thing called, if you go to the overloading method of our subscription, you will see that it says that you can take in a single observer. Apart from a single observer, you can also take in what we call functional interface in your callback. So you can have a consumer that is on sources, a consumer on error as well. You can take all of those callback. So what I'm going to do is I'm going to change from the observer to taking a functional interface in this case. So I will change this and say here that take the functional interface for this, and then take on error itself. So I'm going to copy this into this and say this in Kotlin is it, and I'm going to remove the on error. Yeah. So I'm going to say here that consumer, just so the error goes. And what I've changed here is that I'm trying to move away from using this observer, which is something we can use, but also to let us know that we can use functional interface in this case. In this case of functional interface, it returns a disposable, so which I need to take care of, and then say disposable is equals to that. Then once it returns that disposable, then I can put it inside a composite disposable here, so that I will dispose it later. Yep, cool. Now, yeah, so I just commented that. So I just did some reshuffling just so I can use functional interface. But the interesting thing about this functional interface that I've used is that I'm not handling the on error callback. I'm only handling the on sources callback in this case. So what's going to happen if we're trying to get a user that does not exist? So let's say this. And then I'm trying to run it now. Now, if you look at this, in this case, because we did not undo the on error, the kind of error message that we get is quite different from the one that we got when we are printing the stack trace. Now, this one, if you follow closely in the error message, is saying that we have on error not implemented exception, and this exception was not handled due to an error handler in the subscribe that is missing. So we get this on error not implemented exception, which is a crash in the application. This means your application is crashing and your user are experiencing bad behavior. That's what it means in this case. But then if that tells us what is the cause of this crash, that it's a null pointer exception that you've not handled in your subscription. That is the cause of this crash. Yeah, so that's basically that around it. And what we've done here is for the case of single, or we can also look at that of observable as well. In the case of observable as well, there are two types of observables, or there's auth observable, there's code observable. For this session, I would like to bother us with the details of auth observable or code observables. But what I would just say is that auth observables in itself, they are not the source of the data they are emitting. Usually you use it for your event emission, your button clicks and the likes, because your button clicks are coming from an external event. But what I'm going to do is I'm just going to show us how the code observable works, and just tell us that what an observable does is to emit multiple data that comes out of the stream in itself. So what I've done here is I've created a code observable that using the create method in observable flow. And then what it does is that it iterates to 0 to 10, and then it emits every item in 0 to 10. And then what you have here is you are subscribing using the functional interface paradigm. I've added the on-error method, and then I've added the completion method, which is available in observables as well. And then once you see it, what you notice on this other side of the panel is that your observables are returning the results. You see that it says data observed is equals to 0, and then from 0 to 10. So that is what happens for an observable, in the sense that it does not just emit one item, it emits multiple items. And another thing that is interesting is we can also look at it from the angle of completable, in the sense that it does not emit data, it just completes successfully. For this one, this is trying to save a null data, which is going to return a result into an error, similar to what I've demoed for single as well. But if it's saving an actual data, this is eventually going to be successful for completable. So that and that, we can also look at that for flowable and then try to add back pressure. So for now, because of my time, I think I'm just going to move to trading and see how trading works in RxFlow, which is one of the things that a lot of us will be interested in. Yeah, so I try to put some background around the way I think about trading in RxJava. One of them I said is that if trade is not specified in the Rx chain, the system main thread will be used in itself. So the first question that comes to your mind is, if you look at what we've done with our single creator here, we did not specify any thread. We didn't say that call this operation on this thread, call this on that thread. We just created our observable and we added a subscribe observer to it, and then we executed it and it was fine. So what thread is it running on? It's running on the main thread, and that's the interesting part where we're able to get our result before our main operation terminates. So everything runs on the main thread. Now it also now says that we use something in Java called schedulers. So in Android, it's called schedulers. So we use the schedulers.io for IO operations, and then you can use something around schedulers.computation for intensive logic. For main UI logic, you can just use the schedulers.main thread, Android schedulers, but we will not have that because we're not running an Android application. We're just running within a Java environment. So another thing I would say is that switch your operations on the IO to a different thread and avoid the main thread. And then if you do that, one of the things that comes to people's mind around subscribe on and observe on is that how does our thread switching works for observables? And I think I would like to demo that in this session. Okay, so let's go into this thread demo and see how this looks like. So basically what I've done here is I've created a different class for thread, and then I'm trying to emit 0 to 5 data. And then I'm also trying to print on what thread is this running on. That's what I'm trying to print here. And then in my main method, I created a class object and then added the subscribe on thread. And I also added the observe on thread. Because we can't use the Android, we're not working with the Android system. We're just going to use a different thread called threads or schedulers.single. And so we have a method called do on next here that is immediately after the observe on. And then finally, we have our subscription at this point here. Now, what I really want to show us is every execution in this flow that we have here, on what thread is this execution running on? That's what I want. Okay, so currently based on the default that I have here, if you look at it, we have this print statement in line 34 that we're saying, trying to know from which thread is this data emitting from. Now, if you perform your subscription, the method subscribe on tells us which thread should your subscription run on. That is what this method will do, which is in a way telling us this operation that is happening here, on what thread should it run on. That is what this subscribe on will do. And then this observe on is telling us that everything beneath the flow run on the thread that is specified in the observe on. Everything beneath the flow, just the thread that is specified in the observer. So if you look at this, and then I'm saying that emitting data on, this is the thread name. It says RS cached or thread scheduler 1. So it's saying that it's emitting data on that thread. But now, on which thread do we have this do on next in itself? Then if you look at this place, it says here that do on next side effects running on Rx single scheduler 1, which is a different thread from where the subscription is running on, because we've specified a different thread for it. Now, another thing that is interesting to know is on what thread is the subscription running on, which is, you'll find it here that says that observe data, which is the data emitted is 0 data, and then it actually emitted a lot of data, but it tries to tell us observe data equals to 1 on RS single scheduler 1 thread as well. Now, you'll notice that our observer is observing the data on a different thread, and the observable is emitting on a different thread. One of the things that I would like to validate is that I'll try to move the on next a little above the observe on thread, and then try to see your side effect for your do on next, on what thread does it run on. I feel like this knowledge is very important, because by the time you understand how your subscribe on thread decides which thread something runs on, and your observe on thread decides what part of the flow or what part of the execution should run on that thread, then you'll be able to do your thread management very well. So yeah, this one, I'm trying to move the do on next up above the observe on, and then I'm trying to see on what thread does the do on next run on. So if you look at this emission, unlike the previous one says that it's running on Rx single scheduler 1, but now your do on S is running on the subscription thread. So what it means is that everything beneath this, everything in the flow runs on the subscription thread, except for the ones below the observer. Everything in the flow will run on the subscription thread, except on the flow on the ones below the observer in itself. So that's how the threading works in Java. And another question that comes to mind is, what if I didn't specify my observer in the execution flow? What then is going to happen? So let's say that and see how that looks like. So if you look at it now, because I have removed the observer in the flow, the thread now runs on the subscribe on thread, which is RH cache thread scheduler, as you have seen in the result emitted. So once you do not specify the subscription thread, once you do not specify the observation thread, then it will just pick the thread that is added to the current flow, or just retain the thread in the current flow in itself. So that is one part that I like to cover around threading for this. Another bit that I would like to show us is what does threading means for when you try to perform nested observable or chain observable sequence in itself. So although I've not gotten to this space, but I want to kind of show us the effects that threading can have in terms of concurrent operation. So I'm going to do something like a flat map operation. Like I mentioned earlier, I know some of us might not be aware of what flat map means, but it's one of the operators that we have in RxJava that basically helps us to convert from one observable to another observable. In this case here, the relevance is if you need to perform multiple sequence API calls, or you have multiple API calls that depend on each other. Take for instance, I have server 1, server 2, server 3, and I want to call server 1 first. If server 1 fails, I want to call server 2. If server 2 fails, then I want to fall back to server 3. We can do a lot of those things with Rx, and then it makes it easy for us with a lot of the operators that it has. So I'm going to do something with flat map operator, and then I'm going to try to say that flat map to single, and then I'm going to say single dot from callable. And basically what I just want to do is I just want to multiply the data that is being emitted by 2. Okay, and then if you look at this now in its way, what we've done here is that we have a subscription that emits data, and after that subscription, we are doing another call to probably another kind of observable that probably that does something of multiplying the data, performing further operations on the data, and all of those things like that. And so that's what we have done between line 51 to 53. Now, with this that I've done, I want to show us how the flow is going to look like, what it means for concurrent operations, and in itself. So currently, I have a single in 51 to 53 that I'm not even telling what thread it should run on, but let me see what this implies. Okay, but before that, I would like to say that know what thread this is running on. Print line, let me just say this. Okay. And then you have, cool. So I've just specified what thread is flat map is running on. And then I can then say here that it should, we have here, okay. Then we have the data that is being returned. So my focus is just on trying to show us what threading means here and how it really works for concurrent operation. So now let's focus on line 53, which is the print statement that we're trying to observe. We are trying to say that the flat map is running on RS cache thread scheduler 1 in itself. That's where it's running on. Now, another thing that I would like to print here is the data in itself. I would like to print the data and say that data is equals to this. Yep, cool. Yep. Yeah, so if you look at this, Rx flat map is running on Rx scheduler 1. The data is equals to 0. It says data is equals to 2. Data is equals to 4 on the subscription thread. Now, what's interesting is that you notice that this observable tries to operate based on the sequential emission of each data, which is from 0 to 5. That is what this observable does. It operates on each data as we emit from 0 to 5. Now, the interesting thing is that we can ensure that each data does not block each other and that the emissions are concurrent in themselves. So, the way the data are operated on, based from each emission, they are concurrent. So what I can do here is I can say that I want this observable to run on its own thread such that each data does not block each other and every one of them can run on a different thread. Cool. So the implication of this is that we will not notice that our result does not come out sequential anymore. It comes out in the order in which the operation terminates or in the order in which each thread is able to complete the execution. That is how the result for flat map is going to come out. So if you look at it now, if you look at the print statement, we say flat map on RS cache thread scheduler, and then it tries to use a scheduler 4, and then it says that data is 4. Now, if you look at it, in reality, the first data that should be emitted here is 0. And if you try to multiply 0 by 2, that should give you 0. So, but in our emission, what we are getting is 4 before 0 comes out, even before 2 comes out, and then finally 6 in itself. So the implication of that is that you have subjected this nested observable into a different thread such that each data that is coming out from the main subscription does not block each other anymore. And all of them can execute on their own thread, and we can have something called concurrent operation. So what is happening with this flat map is the concept of concurrent operation where each data are happening simultaneously. If you want them to emit sequentially, if you want them to emit in sequential fashion, then you can use some operators in RxJava like concat map to ensure that the order is sequential. But that's the beauty of RxJava, which is concurrent operation. Yeah, I know there's going to be a lot of questions around thread. We have like 10 minutes to go. But another thing that I would just like to touch briefly, which I may not be able to demo because of our time to take question, is error handling in RxJava. RxJava comes with a lot of error handling operators. that helps you to perform, helps you to fail save your system in a way so your system does not terminate as a result of error, your application does not crash as a result of error. It just gives you some operator to say that if an error happens within the flow, what should Rx do? If you are trying to fetch result from server 1 and you have a backup system, which is probably a local cache for the result. If you've tried to fetch the result from server 1 and it fails, do you have in your system where you can fall back to the local cache and fetch the result? So Rx gives you that kind of capability to say that, look, if there is an error and you have a fallback or you want to do something, you don't want your stream to terminate, we give you that capability to do that as well. So it comes with a lot of error handling operators in itself. And then some of them are like the retry concept. It comes with the on error return. It comes with on error complete as well. Or you can even do on error resume next. Basically all those error operators. So what we can look at, we can just see what we have here for this case, for what I've written here. In this case here, what I have here is a subscription that is going to result into an error. And basically what I'm trying to do is that test a single exception, get the data, is going to result into an error. And then I'm saying that if it results into an error, try to perform a retry on this operation. And because you don't want your system to be like a system that keeps retrying and then the system is probably going to end eventually, you need a way to get out of the retry in a way. So what I've done here is I'm saying that if count is equals to 3, stop retrying. But if count is less than 3, just keep retrying. Maybe the server was just down for a little period of time. Keep retrying, and then let's see what happens. So I can run this and look at what happens here. So this eventually results into an error, and it tries to tell me on error not implemented because I didn't implement error. Ideally, I should have the error implemented so that the application does not crash even after the third retry. So I can have here that says it's.print start quit. So cool. I just added the on error method just to ensure that the application does not crash. And then we can look at how many times is this retry and before it actually resulted into an error. So if you look at it, it says retried at 1, retried at 2, and then because we say that if it's at 3, don't retry anymore, just call the observer on error method in its way. And another thing that is interesting is that I can add an on error return into this. Take for instance, you just want to return a default value into this operation that says that, oh, you just want to return a ProZ user that is default. Ideally, you wouldn't want to do this. So I would say that let's say I like a concept which I would like to quickly introduce. First, I want to map my results, my emission into a result. So I can say result dot success result, and then I can say it, okay? And then I can come here and say that if it fails, give me results dot fails. So in this way, error result, and then it says tryable in itself. Cool. This approach, what I've done here is that, so I can come here and say, let me just put this one here, remove the retry. Yeah. And then, so let me just put a tryable result here. Let me just put a tryable result here that says no pointer exception. Okay, cool. So, and then, so let's see what this is expecting. This is expecting a tryable, and then this is returning an on error return functions, tryable. Let me just say, then result dot error result. So it looks like the error result is something I can cast this. So let's say the result class, just so that is what is happening there. And then let's see what happens. So it requires a success result, but it's saying that it needs to cast. So something is happening with the casting here. So basically what it's trying to say is that it needs a success result in this case. But what I'm just basically trying to demo here is that I can try to return a ProZ user, a default ProZ user without using the cast, and then just say ProZ user put email, no value, and then I put full name in itself. So yeah, default at Gmail. Basically, what I'm trying to do here is I'm just trying to return a default value so that our system does not crash and the emission does not terminate. In the end, this one will result into the success callback and ensure that this is called with a default value. So we can come here and do that. So you'd see that because the error occurred, it falls back to this on error return and try to return a default proxy user. In reality, what I prefer to do is to cast it to a result and then have like a result.success or a result.error that makes, instead of returning a default value to our stream. So that's that about that. And based on our time, I think I would like to start taking questions around this now.
Okay, fantastic. Thank you, Mayowa. This has been a great workshop. We appreciate you for joining us today. And hopefully those who've been able to join have been able to, learn a thing or two. So thank you so much, Mayowa.
Yeah, thank you. Thank you, Messi.
Mayowa, amazing presentation. Thank you for walking us through code, juggling between the presentation and code. It's always lovely to see engineers code live, get errors, solve the errors and what have you. All right, good stuff. Thank you so much. Enjoy the rest of your day or morning or afternoon. We truly appreciate you. Bye.